The evolution of the universe, according to current scientific understanding, is described by the Big Bang Theory. This theory proposes that the universe began as a singularity approximately 13.8 billion years ago. In the beginning, there was nothing but a singularity. Amidst the cosmic tempest, unimaginable forces clashed and merged in a symphony of chaos and harmony. Then, in an astonishingly brief moment, the universe underwent a phenomenon known as inflation. As the universe expanded, it cooled, and the intense heat gave way to a seething sea of particles, quarks and gluons. As time marched forward, the universe continued to cool, and quarks and gluons began to bind together, forming neutrons and protons. Then, in a pivotal moment, the universe finally cooled enough for protons and neutrons to merge, forming the first atomic nuclei. The dominant elements produced were hydrogen and helium, laying the foundation for the composition of stars and galaxies. During this early phase, the universe was still relatively young, and galaxies were just beginning to form. Small structures, such as dwarf galaxies, formed first and then merged to create larger galaxies. Within galaxies, the ongoing process of star formation continued. Gas clouds within galaxies collapsed under the force of gravity, giving birth to new generations of stars. As galaxies evolved, they frequently interacted and merged with one another due to gravitational attractions. Over time, galaxies organized into different structural forms, including spiral galaxies, elliptical galaxies, and irregular galaxies. Many galaxies harbor supermassive black holes at their centers. The growth of these black holes is closely tied to the evolution of their host galaxies. Throughout this era, the universe continued to expand, driven primarily by dark energy. As galaxies evolved, they congregated into galaxy clusters and superclusters, the largest gravitationally bound structures in the universe. Thus, the universe underwent a continuous evolution, expanding inexorably. Its destiny remains uncertain, guided by the mysterious influence of dark energy, which opposes gravity, compelling galaxies to move farther apart. Fresh stars emerge from the remnants of deceased ones. Swirling clouds of hydrogen continue to contract under the relentless pull of gravity, initiating the birth cycle of a new star. It was during this process that a star, eventually to be recognized as the Sun, came into existence. In a swirling cloud of dust and gas, our solar system was formed. Within this cosmic maelstrom, tiny particles collided and coalesced. One of these particles was Earth. Over eons, it grew in size, drawing in more and more matter until it became a solid sphere. As Earth grew, it became a seething cauldron of molten rock. Intense heat from radioactive decay and countless impacts caused the planet to differentiate. The heaviest materials sank to form a dense metallic core. Above it, a semi-fluid mantle churned, and on the surface, a thin crust began to cool. Rain fell from the young, turbulent skies, filling the low-lying basins to create Earth's first oceans. These early waters were nothing like the gentle blue expanses we know today. The atmosphere was thick with gases like carbon dioxide and devoid of oxygen. Life emerged on Earth's shores about 3.8 to 3.5 billion years ago, although the exact moment remains shrouded in mystery. Simple, single-celled organisms ventured forth in a world devoid of oxygen, relying on chemical reactions for survival. Cyanobacteria, masters of photosynthesis, arose, and they had a secret power. They released oxygen as a byproduct. Over millions of years, they transformed Earth's atmosphere, sparking the Great Oxygenation Event and paving the way for the evolution of more complex life forms. Life flourished in Earth's oceans, and about 541 million years ago, an explosion of diversity occurred. The Cambrian explosion saw the rise of multicellular creatures, many with hard shells and skeletons, reshaping the seas in a kaleidoscope of forms. Tectonic plates have ceaselessly rearranged Earth's continents. Mountains have risen, oceans have widened, and earthquakes have reshaped the landscape. This process, ongoing to this day, plays a fundamental role in the planet's geological story. Throughout Earth's history, there have been several mass extinction events, the most famous of which was the one that wiped out the dinosaurs around 66 million years ago. These events significantly impacted the course of evolution and allowed new species to thrive. After the reign of the dinosaurs came to an end, mammals began to diversify and occupy various ecological niches. Primates, including our own species, emerged as part of this evolutionary tapestry. Approximately 200,000 years ago, Homo sapiens, the thinking ape, emerged in Africa. Over time, humans embarked on a journey of migration, discovery, and adaptation, shaping the world around them, building civilizations and advancing technologically. The 18th century marked a turning point in human history, the Industrial Revolution. It brought rapid industrialization, urbanization, and technological advancement, propelling us into the modern world. And now there's a new threat to human existence and many other forms of life here on Earth. Global climate change is causing a surge in temperatures and sea levels, while biodiversity is diminishing. If these trends persist, we may find ourselves on the brink of another catastrophic mass extinction event. But that's a story for another. Be sure to watch the sequel to find out how the world will end. If you enjoyed this video, please like and subscribe to the channel. And as usual, pump your brains. Bye.